Hey guys, it's Miss Sprunger. Today we're going to be talking about rational and irrational numbers. Something that's not too complicated, but if it's not explained well or you don't really understand what's going on or you need to play catch up, need some review, this is a really good quick video to kind of review. So rational numbers versus irrational numbers. Rational numbers can be described in the form of a ratio. So this means if you guys remember back to 6th and 7th grade, a ratio is a number like you can write 4 to 1, you can write 4:1 or 4/1. Okay, those are all ways to write a ratio. Now, the way that I'm talking about writing a ratio is going to be this fraction version. Okay, so 4/1, we can write fractions 3/4, 10/3, -2/3, that kind of thing. An irrational number is a number that cannot be written as a fraction, and you'll kind of see what I mean here in a second. All right, so let's look at this. The real number system. So this real number system that we're going to talk about is what we look at when we are in the 8th grade. You guys are going to be learning about the imaginary number system sort of when you guys get to 9th grade. So here we're mainly going to compare, and this is what you're going to see on the air test as well. You're going to see it's going to want you to compare rational and irrational numbers. So let's understand each of these subgroups while we are thinking about this. So let's start with rational numbers. And rational numbers include all of this stuff in here, okay? So we have integers, whole numbers, and natural numbers. Natural numbers are probably the easiest ones for you to remember because those are your kindergarten counting numbers. 1, 2, 3, 4, and so on and so on. Now, you can count all the way up to 6,000, 6 million. Those are still going to be your natural numbers because they are positive, non-fraction, non-decimal numbers. Now, if we look at your whole number category, notice the only number in there is 0. Okay, and that's because 0 is not a positive non-decimal, non-fraction number. So it's not technically a natural number, but whole numbers include your natural numbers. So whole numbers would be 0, and then all of those numbers over to the right there. Next, we've got integers. These are going to be, if you notice, your negative numbers. So again, still not fractions, still not decimals, but any of your negative numbers, -16, -154. So your negative numbers, and this includes 0, it includes your natural numbers. Okay, so your natural numbers are integers, but integers are not natural numbers. Okay, so it doesn't work both ways. Okay, we've got rational numbers. That includes this whole bubble right here. But if we look at something like 7/3, guys, we've talked about this before, hopefully. That bar right there represents division. So we can actually, if we want to check if it's a rational number, we can just pop it into our calculator really quick. So 7 divided by 3, if we put that into our calculator, we should get 2.333 repeating forever and ever and ever. So if you have a decimal that is either going on forever and ever and ever and ever, and it is repeating, so if you had something like 5.14, 141414 that would be a repeating decimal. If you had something like 8.38153815 and it kept going on, that would be a repeating decimal. Okay, so when we're talking about these irrational guys over there, we're talking about square roots, which I'll make a separate video for square roots, okay? But a square root is essentially when you plug those in, those are going to be your non-repeating. So those are going to be your guys like pi. If you've ever heard of pi, it's down there. Pi is 3.14, but it goes on and on forever, and it's not repeating. It's not a pretty decimal at all. Anytime you have a fraction or a decimal that is non-repeating, goes on and on forever, super ugly. That's what I'm going to call it. That's the best way to put it. And is like 8.1734516 and it's going on and on and on forever, but it's not repeating in any capacity. That is going to be an irrational number. Okay, I'll make another video talking about how to organize these, but that's just a quick overview of how to interpret the real number system, guys. Hope this helps.